My name is Zach Dicus. I am a solutions architect for KBR. My background is I've been a developer in the geospatial remote sensing or in GPS realm for the last 15 years. Today I am representing the USGS out of Sioux Falls, South Dakota. I wanted to talk to you today about a trade study that we conducted earlier this year on moving from Landsat from COG to Zarr. Special thanks to Jeff Hess and Tom Myersberger for allowing me to come here to talk to you today. So a little bit about background about Landsat. It's the longest continuously acquired remote sense data set in the world. It goes back to 1972. We currently have about 15 petabytes of data in the cloud and about 75 petabytes of data on premise. There's quite a few different use cases for it: crop health, forestry, global land cover change, just to name a few. It's used in emergency response and disaster relief, such as wildfires. Currently, we have 2 satellites in orbit, Landsat 8 and Landsat 9, with Landsat Next anticipated in the early 2030s, which will give us go from an 8-day revisit to a 6-day revisit, and also increase our data resolution. So the trade study, we were tasked with completing this late last year into early this year to really explore what it looks like for Landsat to move to Zarr. And there's a couple things that were on our mind when we did this trade study. So what does transitioning to Zarr in the long term look like for Landsat in collection processing? What are the costs? Costs are on everybody's mind nowadays. So how can we reduce storage size? How can we better increase network transfer and improve general efficiency? We also wanted to look at interoperability between other Earth observing missions. And then finally, just prep for the future scale of Landsat Next. So a little more about Landsat data. Like I previously stated, we have 15 petabytes currently in the cloud. Landsat Next will increase that by about 18x. So by 2040, we should have roughly 240 petabytes worth of data in the cloud. So any improvements we can make on storage efficiency will greatly be impacted. Why we are storing so much data is because in between collection processings, we have to store the previous collection and the current collection all at the same time while we are producing it and ready to retire the previous collection. And also our source data continues to get bigger and bigger each year as we grow that archive. So our approach to storing Zarr is to store level 1 and level 2 in the same scene format, so basically creating a spectral cube instead of a spatial temporal cube. For level 3, we would change that to be the spatial temporal like you would expect in a global data set. Each of the bands would be stored in its own resolution variable, and quality bands and things like solar angles will be stored in their own variables called geometry. We would store multi-scales, but only for the purpose of WMS on our use case. It wouldn't really be for the end users themselves. So this is just a visual representation of that structure. So as you can see here, we break it down into 15-meter, 30-meter geometry and quality variables. We do have a consolidated metadata at the top level for the entirety of the scene. And then things like MTL, custom metadata will be stored in Z attributes. The photo on the left is that breakdown, and then on the right is the breakdown of the data tree itself. So for test data, we used 20 scenes, which was a mixture of different products and different satellites. We used a variety of combinations of chunking, compressions, and multiscales to really understand what best fit Landsat. For compression, currently what we do for COGS is we use deflate compression with 256 by 256 blocks with overviews of powers of 2 up to 64. We did test just updating the compression to Z standard for cogs and updating the blocks to be larger because with that with Z standard, the decompression really improved reading. And we saw a 12% savings on storage alone just by doing that. When we move to Zarr, we use Z standard on all of our testing because of the fact that we're really worried about reading. We write all of our data pretty much once with some caveats there, but our data is read thousands and thousands of times over, so reading is really where we wanted to concentrate here. We did run a test with no multi-scales just to see what the storage saving was, and we did see about a 35% savings, mostly because you're removing overviews at that point, and you're just getting a better compression. When we did inject the same powers of 2 multi-scales, we did see about a 20% storage savings, which is really great to see. When we did test, we did actually do a quick test just to do apples-to-apples comparison of Zarr to COG in storage using deflate, when we actually saw a 3% savings just by moving to Zarr alone. With version 3 of Zarr, we did create sharded data sets, and we used 10x the chunk size, which basically means we put a singular band into a shard at a time. So our data is always in intelligent tiering. With Zarr, it actually does provide a opportunity to not warm up all of the data from cold storage at any given time, depending on how our users access the data. So if they're only needing a small chunk of a scene, this will allow us to only warm up that data and save. Also, some of the Zarr benefits, you do get an increase in Zarr partitioning API limits just by the way Zarr is structured. A good note there, though, is for those who are using high throughput services, you do need to put a request into AWS to actually increase your throughput limit on partitions. We hit that limit many times and had to do that request. So, I thought Julia's talk earlier was really great about Stack and its integration with Zarr. It actually does a fairly good job, and there was really no concerns there for us on our perspective. The big thing here is we would probably want to utilize additional add-ons or plugins for Stack. Visualizations is really where we found the biggest negative when it comes to Zarr. Really, there's not a lot of great support for visualization tools right now. GDAL and X-Ray are supported those are supported. ArcGIS and QGIS has a little tiny bit of support. But for our use cases, we investigated Vizar, Napari, and Big Data Viewer, but for every one of these tools, you basically have to write custom configuration or custom software to have that recognize your structure, which isn't great. A huge benefit there, though, is for WMS. We did investigate TI Tyler, which was almost a drop-in replacement for what we needed. So that was a really great benefit there, because that was one of the things that we use for a lot of our tools today to visualize the data for our end users. Speaking of end users, they're well acquainted with COGS, right? They've been using our data for a very long time, and COGS have kind of been the standard. So we don't really want to disrupt that, but we do want to push the limits of what our storage can do, and also just getting the benefits of the performance of Zarr. So there would also be a learning curve to the new tools that they'll have to use. Maybe they're not using X-Array, maybe they're not using some of the tools that Zarr benefits from. There's a brand new storage structure if we move to Zarr. And then again, they're going to have to get used to a lot of new visualization tools. So for our end user community, there's probably a big impact here to switch to Zarr. If we do switch to Zarr, we would really want to provide a lot of training, give the end user community advanced data sets before we do collection processing so they can get used to it way in advance, and probably do workshops so we can get community feedback and understand what the holdups are for maybe adopting Zarr, or maybe just get general feedback from anybody. So I think a lot of people have discussed this today, but Zarr version 2 versus version 3 and the number of objects, comparing sharding. So we have about 50 million scenes for Landsat current to date. If we look at Zarr version 2, that means about 1,200 objects in S3. Version 3 has 170, and COGS obviously have 22. So if we think about collection reprocessing for Landsat, that means we have to do 50 billion API requests for deleting a collection for version 2. And as we grow and we get into Landsat Next, that's going to increase to probably hundreds of billions, even for version 3. So we really need to be cognizant of when we need to delete things, because we don't want a permanent data set. When we talk about file size, so version 2, with our normal multiscales, we saw that 19% savings. When we did a smaller subset of multiscales that we felt could actually support the WMS needs that we required for our user interfaces, we saw about a 33% savings. When we went to version 3 and did the sharding, we saw a 15 and a 28% savings with those same settings. Version 3 is obviously the way we want to go based on the number of objects. So this is just really doing a version 2, version 3 comparison. So we talked about reading being our main use case and our main concern. So we did a read comparison with those 20 data sets, and we did 25 different runs on each data set for version 2, version 3, and COG to see what their performance was on full band reads and 100 chunk reads consecutively. All caches were cleared between these runs to ensure no data was cached in memory, and that's the system we use. So we use 8 cores, 64 gigs of memory, and a 25 gigabit per second network connection to the AWS backbone. For chunk read times, so for the 100 consecutive times, we saw that version 2 Zarr actually beat out version 3 here, but when we're doing this consecutive reads and we're having that overhead of shards, that's to be expected. But as you can see, the performance gain off of COGS is actually pretty big. So there is a big performance gain to have when you move to version 2 or 3. When we talk about reading full bands or the full data set itself, you'll see that version 3 beats out version 2 because when you're only having that overhead of the shards once, it doesn't have as big of an impact. So we see Zarr version 3 actually come out ahead with COG, staying pretty consistent about twice as long. So for our conclusion, Zarr v3 really does meet the needs for our storage efficiency, for our cost reduction, and for distribution. We would plan to probably zip that up as a singular Zarr dataset on the fly, not for direct access, obviously. Direct access, it'd still be in its native format. That would just be for the offering of the free download. It does meet our network requirement as well. So we allow 65 terabytes per day to be downloaded for free to our end users. If we can reduce the size that we're distributing, that means we can distribute more data, right? Individual scenes would be required for Zarr datasets for level 1 and level 2 just because of the spatial temporal sparseness. We can't create anything else unless anybody else has any ideas out there. And if we do move to Zarr and implement that v3 with the smaller multiscales, we can save about 45 petabytes of storage and increase the amount of data in cold storage over that time. So thus saving more money. And then we do want to maintain interoperability with other missions. So we do want to continue to query the community and see what the needs are. And it is great for direct access and AI ML users. So there is still work to be had for this. And mainly what I wanted to do for this conference is to tell everybody about what we've kind of done and get everybody's feedback and understand what the needs of the community are. So with that, if you do have thoughts on Landsat and things I can take back to back to Eros, please talk with me after this, but I'd love to answer any questions that you have about the trade study that we did. Yeah. Can you
talk about what tool you use to to access the entire file. So you said you loaded a whole Zarr v2, a whole Zarr v3, and all the files out of a cog package.
Yes.
Yeah.
We used Xarray to basically do everything on that from that perspective. For cogs, we used Rio to do that. So, but all through Xarray.
Yep. Did you do any tests loading lots of files? Like one of my use cases is like full time stack over a 5,000 pixel region, so 2,000 scenes maybe.
I was more concerned about the scene level because that is really where the use case for us is most needed. Obviously, there's for level 3, there's lots of different use cases or examples out there. There's not really anything for level 1 and 2 in level 1 and level 2. So that's really where I was concentrating on the scene level because that's how a lot of our end users access a lot of the data is at the scene level. So that's really where I wanted to concentrate the most.
Level 2 level? You make
level 1 and level 2.
Yeah.
Yep.
That's what I'm talking about.
Then I haven't run a test on that, but maybe that's something I could add. Yeah.
Maybe one question and then maybe a bit of a plug. How are you serializing your CRS representation within the structure that you have now?
So we were, that's a good question. We are trying to follow the GeoZarr format as much as possible. So.
And as a plug, yeah, we have this specification we're working on called GeoZarr.
I actually meant to mention that during the presentation. I might have missed it in my notes, but yes, we are trying to follow the GeoZarr spec as much as possible.
It would be great, actually. I mean, because we're in so much flux right now. I wish Brianna was here, but we could. We would really appreciate like larger stakeholders like USGS providing us some feedback and also giving us some use cases that we can experiment with. Because I think the small individual granular use case is one we're not exploring as much. So yeah, it'd be great to get your feedback and get some of your representation in the meetings that we have as well, for sure.
Yeah, that would be great. Yeah, whoever wants to go next.
Great talk. I'm curious, the version of Zarr v3 that you used and the DLAC store that backs it matters a lot because the actual code that is going and fetching the chunks is like the FS-spec Python library. But now, as of like a couple of weeks ago, there's an alternative implementation in the Zarr Python that uses Kyle Barron, his OpStore library, which is potentially faster. And then on top of that, there's also the IceChunk library, which has its own Rust, which uses a lot of the same like object store Rust crate. But basically the point is like, did you use any of those? They might be even faster.
So that's actually a great question, and that's why I'm really interested in your talk next, because I do want to experiment with OpStore a little bit. But we were using obviously FS-spec is the default. But yes, that's one of the tests I actually want to run. And after I saw your talk, I was like, okay, this is perfect. I get to listen to your talk and
Kyle's talk, right?
Kyle's talk.
Kyle's talk. Yeah, wherever he is. Yeah, cool. Thanks.
Yeah.
So
Sorry.
I was just wondering, is USGS talking with ESA at all? Because I know ESA is planning to do the same thing basically with Sentinel-2 and L2I, and they have all their structures of what they're planning to do all up. It's all there.
We're still in the initial phases of just understanding what it means to even go to Zarr. There's no decisions being made, and that's definitely above my level. I'm just trying to report on the technical aspects of it and get community feedback.
Yeah, I would really recommend looking what they're doing so that you can, like, as part of aligning with what other people are doing. Even if you have like feedback on what they're doing, maybe like just look at it.
Yeah, and that's where the interoperability with other Earth observing missions comes into play. Is we do want to adopt, similar approaches, right? We don't want to completely go off on another. So, all right, we already are over time, so I want to make sure we give others time. So.